I'm Professor Shifan Chen. I'm the instructor of multi-agent system. So this is a new class in the MITP program under the AI track. So this particular term might be not so familiar with a lot of you. So let me explain in more detail. So agents, this is the first important element. In most of the artificial intelligence technology, agent refer to any individual that's making decisions independently. So this individual can be a real person, it can be companies, it can be countries, or even the whole population, right? So there's really no limit as to what agent can be used to represent. But most of the time, if you look at those technologies, agents refer to really independent decision making, right? But a lot of cases, when you make good decisions, you need to consider your peers as well, right? So one classical example is just to think about routing, right? So you want to go from point A to point B, which is very common. You just take out your phone, you start your Google Map, you want to find the shortest route. But now imagine, let's say, tens of thousands of people, they have very similar origins, and they are all going to very similar destinations. If you just follow the single optimization algorithm, you find the best possible route. The route will be very similar. And the originally best route that you are supposed to take might not be so good anymore, right? So this is the classical example where when you try to come up with your own decision, you have to consider others as well. And this is basically what multi-agent system is all about. You try to make your own best decision, but at the same time, you try to incorporate and anticipate what others might be doing, right? So we will cover a lot of different examples in business, in economics, in financial markets, so on and so forth. And in terms of approach, the kind of approach that I will take in this class will be both theory-based and also practice-based. Theory-based so that we have necessary mathematical tools to understand this whole concept of multi-agent system. We can represent that, we can analyze that. But practice part is equally important. We need to be able to create a hands-on system. We can play with it. We can try out different strategies for individual. We can make observations about how different strategy can be put together and gradually improve. And of course, to cap the whole course, I think one very important element is for individuals to come up with projects. That projects can be coming from the domain knowledge of individual students. It can be proposed based on their own observation of what's going on. But this is really the chance for students to use whatever they learn in class to try to come up with their own solution, to view the problem as a multi-agent system, propose solution, and see what the impact of the solution will be like.